So moving forward with our video regarding functions, so when we left, we had created a function that doesn't return anything, and we'll explain that soon. And we add two numbers, and then it prints to the screen the result of adding those two numbers. So let's get into a little thing called variable scope, because this is important. So we've got our variables a and b, and then we've got our two variables I and j. And in the last video, that was a little bit purposeful because I didn't want to reuse a and b because I didn't want to confuse anybody. What actually happens is, as I mentioned before in the previous videos, if we were to do an I and j, and then further down we tried to again use I and j, that wouldn't work. Well, what happens is we have within functions, it's called variable scope. And there's actually other areas, but because we're defining all our variables at the top of each function, we side skirt that a little bit, and we don't have to worry as much as scope as we would normally need to. So within our function, we have our a and b, and that's only local to that function. So if we wanted to reuse a and b within main, and then we're not adding I and j anymore, we're adding a and b. We get the same result as we did before. So that's something to keep in mind, is the scope of the variable. Right now, the only scope you'll have to worry about is within each function. So if we, within this function, if we tried to make a new variable a, that wouldn't work. That would give us an error. So we get build errors, and then we redefinition of a. So the reason we can reuse those is how the program is kept. It's kept in something called a stack, which is actually one of the things we'll go over later in this course. But for now, you don't have to worry about it. Just remember to be in the habit of declaring all your variables at the top of your function, and in that case, you'll be able to reuse variables. Because what would happen is if it wasn't stored like that, say we go to use somebody else's code, like for example, we're using IOStream, and we don't know every single variable name that they used within IOStream, so we would run out of variables to use very quickly. So that's why each function gets its own what's known as a stack area, and then we can actually reuse variable names for that reason. So that's something to keep in mind. Okay, so now let's move on to return types. So right now we're just within our function, just printing to the screen. But what if we wanted it to use something called a return type? And the reason for using a return type is because while we're printing this to the user, what if I had a bunch of functions and I wanted to take this add two numbers and I wanted to feed it to another function called multiply two numbers? Right now we wouldn't really be able to do that. We would have to call multiply two numbers within this function. But what if we wanted to put that in main and we wanted to reuse it a bunch of different ways? So what we can do is we can declare something called a return type. And what you might notice is this is starting to look an awful lot like our main. And that's why we have our return 0, is because our program main is actually the main function of our program. It's the entry point. And when it exits, it actually needs a return value that it passes to the operating system. So instead of displaying to the screen, what we're going to do is we're going to do something called a return type. Oop. I'm going to do a plus b. Okay, so this is similar as before, but we're not printing to the screen. So what we're going to do is we're going to call our add two numbers. Let's just call it as is, so you can see that our program has changed and it's still compiling and everything's good. Okay, so we have a program that executes code, but as far as we're concerned, it doesn't really do anything. We can't see it doing anything. So everything's being done in the background. So let's do this now. Let's take the result of add two numbers, because that's what that function returns, and let's print it to the screen. I'll run this and then I'll explain it. So we can see our add two number function, a and b, is going to equal 3. Well, this is kind of interesting because before we had just used variables or strings, and so what happened is this function returned an integer. It returned the number 3, and it's that number 3 is sitting somewhere in your computer's memory, and a variable basically does the exact same thing. So we've taken that and we've printed it to the screen equally. So there's some location in your computer's memory, and we actually had it print that. So maybe it'll solidify a little bit more if we do this another way. So now we're taking our add two numbers function that we created that returns an integer. It takes our two numbers in, adds them together, and then it returns it. So what we're doing is actually storing it permanently in a variable. So the function runs, and then it has this number to give back to us, and now we're storing it in result. And so anytime we want to use result again, we can, because it's not just a one-time thing. So let's go ahead and run it to make sure it still runs correctly. So we see add two numbers, it equals 3. But this time we're actually reading from result, which contains 3. And so I hope you get a sense of why those two are, they're a little bit different, but the end result is the same. It's because it's taking the result of add two numbers, it's storing it in a place in memory. In the first example, it's storing in a place of memory at that exact runtime, and we only can use it once. But when we actually store it in a more permanent place inside that variable result, we get to use it again. So I'll cut the video short here, and we'll move on with some other things in the course.